Hi everybody, so here's 5.4, which is fundamental 2. So warm up here is just asking you to anti-derive these definite integrals with limit of integration, remembering where you have a linear chain, and then in the second one, making sure you treat them as rational and negative exponents before you anti-derive them. So pause the video, work through these on your own, and then check your work with mine. So for your two answers for your warm-up, you should have negative 1/2 e to the negative 8th plus a half, and 47/12. Okay, so FTC part 2, part of this section brings in this idea of, well, what if we want the area as a function? We have an initial point or a starting point, an a value, and then it goes on until x, some unknown value. What does that look like? So a question would be phrased, what is the area under the curve, or under y equals t squared, from 3 to x? So in this section, you'll commonly see t as your input of your function or equation, and then x is the input of the limit of integration. So our problem begins as integral from 3 to x of t squared dt. We anti-derive, and we would have t cubed divided by 3 from 3 until x. And then when we evaluate with the upper limit, x cubed over 3 minus the lower limit, 3 cubed over 3, we would write this as a 1/3 x cubed minus 9. So now the integral, or the antiderivative of the answer, is written as a function still, as opposed to a value. Okay. So the second one, done exactly the same way. Right? Add 1 to the exponent, divide by the new. So you would end up with 2x to the 6th well, first of all, you would start with two t to the 6th from 1 until x. And then you would end up with 2x to the 6th minus 2. I'll leave both of these for you to try on your own. And then I want to investigate this next example together. So if I'm given that capital F is equal to the antiderivative, or the integral from 1 to x of t squared minus 2t plus 3, and ultimately I want to find big F prime. So in order to get there, I'm going to anti-derive this first. Okay, so I'm going to go through the motions in this one and investigate, see what happens. Right? If you have some kind of an idea, hypothesis, go ahead and kind of say it out loud or jot it down in your notes. But I'm going to go through this blindly. So if I anti-derive first, I would have t cubed over 3 minus 2t squared over 2 plus 3t from 1 to x. Right? Then I would have 1/3 x cubed minus x squared plus 3x minus 1/3 minus 1 plus 3. Okay, so 1/3 x cubed minus x squared plus 3x, and that would simplify to minus 7/3. And this is my big F, right? The problem says find big F prime. Well, now I just derive it, right? So 3 times 1/3 is 1. Reduce the exponent by 1, x squared. Drop the 2 down, so I would have a minus 2x plus a 3, and the 7/3 derives to a 0. So isn't this exactly what I started with, except x is now plugged in? Interesting. So FTC Part 2 says exactly what we just found. First of all, the area, or the function written as area as a function of x, the area function, is the integral from a to x of f of t dt. So those are the first couple of examples that we did. And the second one is that if we derive the integral, the answer will be f of x, right? If we derive with respect to x the integral from a to x of little f of t dt, then the answer is little f. It brings us full circle. If f is continuous on a to b, and big F of x equals this integral, then big F prime equals little f of x on AB. So for example, the first one is what we saw before. I can go right to my answer of saying if I am going to derive an antiderivative, or if I'm going to derive an integral, right, they're essentially opposite operations, then I'm going to get back to where I started with. The only thing I'm doing is replacing the t's with x's. That constant that we found didn't matter, because whatever constant I come across, right, so whatever that lower limit is, it doesn't matter. The number will always cancel out because I'm deriving it. I'm anti-deriving it, doing f of b minus f of a. The f of b, which in this case is f of x, will stay, but the minus f of a portion, when I derive it, will go to 0. So the number will always cancel out. Super important. It doesn't matter what that number is down there. It matters that there's an x up top. If they were reversed, I would need to use that property of applying a negative so I can reverse my limits of integration. All right, so literally these problems are as simple as acknowledging that you're deriving an integral. You're doing nothing almost, except replacing the t with x. So root 1 plus 2x, done. Root 1 plus x squared, done. You don't need to go through the process. You need to acknowledge that you're being asked to derive an integral. FTC Part 2 says just replace the t with x. Okay, so, right, seemed a little bit too easy. There's always a catch. When things are too easy, there's always going to be a catch. Here it is. Remember that chain rule that we did back in Chapter 3? What if we are now inputting something other than just x? Right? What if that upper limit is an x squared? Let's investigate this. This one we can investigate. So let's first antiderive this. So then sine antiderives to negative cosine, which, based on these limits of integration, would then give us negative cosine of x squared minus negative cosine or plus cosine of negative 2. So this is some number. I don't know exactly what it is. I don't really care. But it's a number. So now if I derive this, when I derive the negative cosine of x squared, I need my chain rule. So I have a negative already. Cosine derives to negative sine times inner prime times 2x. So my result is sine of x squared times 2x. That number, that cosine of negative 2, went to 0. So right down here, here's your rule, or your kind of addendum to the rule. So if the upper limit of integration is not x, right, it's something other than x, then we need to multiply by the derivative of the upper limit. So whatever this is, we multiply, we insert to wherever the t's are, and we multiply by the derivative of that upper limit. All right, let's put that into practice times. So plug in and multiply by inner prime, I call it. You can refer to it as inner prime because that's what we did with the chain rule, right? And it becomes the inner when I plug it in, or upper limit prime. I'm saying the same thing in both of those. Okay, so I replace my t with 1 over x. And I multiply by the derivative of x to the negative 1, or 1 over x, and that's negative x to the negative 2. And then I'm done. Don't do any extra work. Don't try to prove these. Some of them you won't be able to. So you have to know how to use FTC Part 2. Okay, x squared. Replace the t. Everything else stays the same. So e to the negative x squared squared, or negative x to the 4th, plus 1. Multiply that whole thing by 2x. Okay, I'll leave these for you guys to try on your own. And we will recap together in class.